Okay, just taking a look at this solids in contact question. It was that one of you requested it on Edmodo, so I'll have a look at it now. You're given the elevation of a cone and a sphere B, which is directly in front of it. The elevation is given, measurements are given, and you draw a plan view from that. So part A of the question is pretty straightforward. The query related to part B and part C, so we're going to take a look at those now. So in part B, what they're asking you to do is to draw a second sphere resting on the horizontal plane. Now, when it says horizontal plane, that means it's resting on the ground. So this has to be on the ground, the sphere that we draw. And then the other criteria put in place is that it has to be in contact with the given sphere, which is the larger one, at a point which is 18 millimeters above the horizontal plane. So 18 millimeters above the ground. So this is the third sphere we're going to draw, and it has to be in contact with this one, and those two have to be in contact with each other at a point which is exactly 18 millimeters above the ground. Now that doesn't necessarily mean that the radius of the sphere is 18 or anything like that. It just means that the point of contact is 18 millimeters above the ground. So what I've done is I've drawn out the question, but I'm just going to go through it slowly now. So the initial setup of should be okay for everyone. Drawing the existing cone and the larger sphere, which is perfectly lined in front of it. And now what I'm going to do is I'm going to focus in on putting in the extra sphere, the smaller one. So I'll focus in on the elevation. Okay. So what I've done is I have measured 18 millimeters up from the ground line, made a mark, and put a line across. Now, where that cuts through the edge of my existing sphere, that's the level at which the sphere that I'm going to draw has to be in contact with it. And when you have two circles or two spheres appearing to be in contact with each other, you find the point of contact by joining the two centres together. Okay, so that goes back to junior cert graphics. So what I have in this case is I have the centre point of one of the spheres, and I have the point of contact. So what I'm going to do is I'm going to draw a line going through those two, like so. Now what that means is that the centre point for the other sphere has to be somewhere along that line. So what we're going to do now is we're going to try and find the centre point of it. So all we know about it for now is that it's along this line somewhere. Okay. What I've done then is I've created a loci. Now a loci is basically just a path that centre points can take. So what I've done is I've started off with the radius of the existing sphere, and I set that. Now what I did then was I added 10 millimeters onto that measurement. So when I brought it out by 10 mil, I struck an arc. And at the same time, I measured up 10 millimeters from the ground and drew a line across, and they intersected each other. So that would be one possible location for a circle or a sphere that will be touching the ground and touching this sphere. But it's not on the line that I want, so I'm going to keep going. So what I'll do is I'll take a series of samples, and then they'll begin to create a path or a profile for it to go in. So then I go back to my sphere. I added 10 on the last time. I'll add on another 10 and strike another arc, and this time measure up 20 from the ground. Draw that line coming across. Now again, that can give me a sample centre point. If I drew a sphere from there, it would be in contact with the ground and would be in contact with the sphere I have, but it wouldn't be in contact at that particular point, the line that I want. But what I can do is I can create a path between those two, starting at the base here and just curving it around, and that path is known as a loci. Now that loci that I've drawn crosses over the line that I need my centre point to be on. So that finds it for you in elevation. So all it then was, that's my centre point, stretch it back to where my point of contact is, and drawing the elevation of your sphere. Then to bring that down to plan view, I just drop down the centre. I put them touching side by side. But you could, if you needed to, you don't have to in this question, but in some other question you might have to maybe take that as maybe a sample position and then move it back towards another shape. You didn't have to do that in this question, but so I just put them side by side. Okay, so that completed my plan view for me. Now to go back to the question, looking at part C, which was also I has to go through it as well. So we look at part C of this question. What they want you to do is to draw the traces of a tangent plane. Now a tangent plane just means it's touching against whatever they're going to specify, so it's the same as we're usually working with. We're looking for a horizontal trace and a vertical trace. And the two shapes that we're dealing with is the cone A, which is the original cone, the large one, you can see it here, and sphere C, which is the one that we just drew. Now just another pointer before I go and answer this. You obviously need the answer from part B to attempt part C, because you need sphere C. If you for some reason didn't or weren't able to figure out part B, you would just put an estimate of what you think it would look like, carry on, and then if you get the procedure for part C correct, you still get the marks for part C. So if you're ever stuck like that, just make an estimation of what you think it should look like, continue on, and you might still get a good bulk of the marks. Right, I'll just zoom out for this because I want a view of both elevation and plan. Now the procedure for this is quite simple. What we're going to do is we're going to try and put a cone over the sphere that I have, because if you have two cones, it's quite easy to rest something against them, and what we want to do in this case is want to rest a plane against them, and we can get the traces of the plane after. So what we'll do is take the sphere C, the smaller one here, and we're going to put a cone which has the same angle as my existing cone on top of it. So all that's going to mean is, in elevation, getting the angle of the cone, the pitch of it, and just sitting it on top of that sphere that I have. Okay, and we go in both directions, just so you understand what I'm trying to do. So now that I have two cones, it's going to be very, very easy to rest a plane on top of them. And it'll be in contact with the sphere because the cone that I drew is just tangential to that. So when I put the plane on top of it, it'll still be touching the sphere. The cone is just an imaginary thing that we put in to help us get the angle right. So what we'll do then is take the cone that we've just put over this sphere and bring it down to plan view and draw it down there. Now as you know, a cone in plan view just looks like a circle. So get the radius of your cone on the ground and have it sitting on top of that sphere down in plan view. Now when you have two cones and you rest something against them, the horizontal trace is just going to be tangential to the two cones. So I could do a horizontal trace going in that direction, probably be the most sensible way. Or you could also put one going up that way. Okay, it wouldn't make any difference, to be honest. I'll just put it here just to keep the drawing tidy. So I'm tangential to the edge of both of them on the ground. That's my horizontal trace. The vertical trace is found, as we always do. Once you get your horizontal trace, go to the highest point of what you're talking about. So in this particular case, we're talking about two cones. One of them is higher than the other one, so go to the highest point here, center point of it, and replicate the angle. So that's my horizontal trace angle. Slide it over. That's it, replicate, so they're parallel to each other. And then just bring that up and take a height reference over from it. And that is the vertical trace. Okay, so essentially what we've done there, just do a really quick sketch just to try and help to explain it. So what I'll draw out is, let's say we have the corner of a room, like so. So that's your back wall, that's your ground, and let's say we sit two cones on it. Okay, and we put maybe another cone a bit closer. Now, if we were to sit a sheet of glass on top of those two cones, it would rest against the ground tangential to the two of them, like that. And it would be pitched, obviously, at whatever angle the cones are at. So that's essentially what we did. That's our horizontal trace. and as we're looking down in plan view, we just see that as a single line. And then the vertical trace, the VT, is as we're looking in for the elevation. Okay, so hope that helped, and like I said, lads, if you have any questions that you're not sure how to answer, just request them on Edmodo and I'll do a video for you, no bother.